universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light. And I've heard others call from light years away. And they're real, and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars. And I've heard others call from light years away. And they're real, and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hey everybody, and welcome to SkyTour Livestream. It is I, Marc Antonio, and of course we have with us, as always, Darrell Mason. Hello Darrell, how are you?
Hello, Mark. I'm good, thanks. You? Hello, everybody.
Doing just fine, just fine.
Good.
Yeah, and it's going to be a good night. It should be fun, I should say, because we're going to be checking out some really interesting stuff, because why not? Because we can. So, as well as this object here that we're looking at right there, we're going to be checking out others. Now, you say, well, those aren't objects. Those are stars. They are. But if we do a long exposure of this area, now check out what's really hiding back here. Let's do a 20-second shot. Now, it's still just about dark out there. So, might have a tinge of red or blue in here. But we can eliminate that right away. But welcome to SkyTour Livestream. Renee Cruz is here. She was the first. Okay, that's the old one. I was doing some test shots earlier. And Renee Cruz is there. Tim F is here. Nice to see you. Judy M is with us. Hi, guys. And Ricky Ricardo, how you doing? All right, let's now get rid of all the brightness we don't need and start by doing our work here. Okay, there we go. This is a very, very special location in our universe. This is called the Sagittarius star cloud. All right, and you can see that there are dark dust blobs that are between us and the further stars, and here these will have wisps on them as it pulls along further into exposures. It's just doing has to build up, because we take an exposure, take a second one, and we stack it on top and make an image sandwich, and that image sandwich allows us to see all the really, really detailed stuff in there, because all the dimmest stuff rises to the top of the heap, and it's really great. And then that's called stacking, and that stack we're making dynamically, so each image is stacked with the previous. And the guider is doing very well right now, so we can see this beautiful image start to come through. You know, this is looking pretty much toward the center of our galaxy. We're not quite looking toward the center of our galaxy, but it's pretty close to looking. We're looking in that general direction, I should say. So we would see the densest stars in this region quite often. We'd see that, and that's what we're seeing now.
This is Messier 24.
Yes, it is. You're seeing that up there.
Yeah.
Isn't that here?
Small Sagittarius star cloud.
Yeah, that's a small Sagittarius star cloud, this whole thing. But Messier 24 was a cluster within it, wasn't it?
Nope.
Let me go back. And
I do believe small Sagittarius star cloud is M24.
Okay. I guess that's yeah, okay.
Nice little star cluster.
Yeah. What's interesting is that star cluster, if you look at our red square over there, that red square is the field of view, all right? And that cluster right there is NGC 6603, which is that cluster right there.
Uh-huh.
Yep.
Pretty
Very
field.
nice. Yeah. I want to check out this too right below it. After we pick up a few here, we'll go to 10 on this. You can see these dark clouds are actually starting to show some detail now. And we can see what's really there by punching it up drastically. This is overdoing it. Okay, but you can see now, that's what it looks like. Look at that.
Very nice.
It is nice. Actually, we can actually leave that there and utilize that. Yeah, look at that. I did put the telescope through a focus already, so we already have it focused. Hey, Do is with us. Do W. Anahata, hi Bonnie. UFO bro, what's up? Marco, hi, how you doing? C&D boy, Lil King 420s, how you doing? What's on the teledocket this evening? Hey, that's a great way to put it. Well, on the teledocket, we're going to check out some really cool objects, including these wispy, dusty structures. Without the moon, we can really visualize these very nicely. Because even with all the special filters we use, the moon does interfere. Its light does interfere with the things that we're looking at. You know, even a little bit.
Moon's a waning crescent in the morning sky now. It was near Venus this morning, actually. My brother emailed me and said he saw it. And I looked it up, verified what he was saying, and turned out they were right on either side of the bright star Regulus in Leo.
Oh, very cool.
Sure, it made a pretty view.
Yeah. So this is pretty. You can see these wisps trailing behind. If you think about it, I've talked about this so many times. These dark clouds in the universe are really almost everywhere you look, you'll see dark clouds in a nebula or a galaxy. It's very rare that the dark clouds are not present. Usually in elliptical galaxies, there's not a whole lot of gas nor dust, but we do see dust, as in Messier 110 in the Andromeda Galaxy. That's a satellite galaxy that's an elliptical, and it appears to have some dark dust in it. You know, another thing too, which is really interesting, it looks like the James Webb has found some really fascinating information out about elliptical galaxies. Elliptical galaxies are giant spheres of stars, at least to the telescope we use, to the telescope that has been even Hubble traditionally used. You see these giant ellipticals as just giant spheres of stars. However, with the James Webb, we're finding that those galaxies actually have spiral arms, but in many cases, but they're in the infrared, so you can't see them. So does that mean that they're forming spiral arms, and that galaxies start as a nucleus and then the disk forms later? Who knows? But many very distant galaxies, ellipticals especially, are showing this trait. So we might be seeing some form of galactic evolution at play here. Yep. So, I said I'd go to 10, we went to 18, so we'll say this, I'll name it, okay? And if you go to skytourlive.org up here, you're going to find also that we have Messier 22, the globular cluster before it. I did it as a test. It looks stunning. And so you can download that as well for free. Of course, everything is free up there. All right, this will be the small Sagittarius star cloud. I'll wait till 20 now that we've been talking. 1 second left. We'll go to 20 up here. That's how many we've done. Bango. And now I can save it. And you'll see a green bar up top indicating that we've saved it. Okay, there it is. It's been saved. And now I'll save it exactly as seen. And by saving it exactly as seen, we're going to save the image. Now, what does that image look like? I'll show you. I'll click on it. And right here, this is what's up there now in our directory that you can then download. Right there. That image is yours to take for free and enjoy it. All right, that's a Sagittarius star cloud, the small Sagittarius star cloud. Okay, so that said, one of the things that we want to do is, first thing I want to do is get rid of this. Okay. All right. So now I want to go check out something that's just a little bit south of here. So we're going to get out of this and go back to our night vision mode, which we like to use to visualize what we're seeing before we actually expose it for a long period of time. Okay, so here we go. All right, so now let's go back to this planetarium view and let's go check out IC 1284. It's right nearby, and it's a very colorful nebula. It's also known as Sharpless 2-37. And should come winging into view here in just a moment. All right. I'm also going to do one thing really quick. I'm going to take away that view and bring up a different one. Okay, I'll be right to you in a second. I was not happy with how slow, there was a delay there and I didn't like that, so let me just bring it up again. Okay, it's not that, it's gonna be this. All right, there we are. Okay, and let's bring this down. Let's get this back where it belongs. There we go. Okay.
All I see is a picture of you.
Yeah. You must be looking on YouTube.
No, I'm looking on Skype.
Oh. Well, that's because I have to reshare the screen for you, which I'll do right now. Okay. So now, okay, we have this view, and right in here, we should have this nebula. It looks like it's right here. So let's just do a 25-second shot of this right now. And let's go right to our live stack, remove the Sagittarius star cloud, which, by the way, that's what it looks like when you really push it. That's crazy, huh? Look at all that detail. We'll be able to pull that out without overexposing. Okay, so now we clear this. And now we're going to, in 5 seconds, we're going to see what's there. I'm looking forward to this. Okay, it didn't wait long enough for it to grab the... I didn't wait long enough for it to grab the star, so my mistake. Let's do this. I should say the guide star. It's a little elongated because it didn't start guiding right away, so we'll let it do this. That looks like... don't worry about that. That's going to disappear. I wonder if that's the Angel Nebula. I don't remember. Sharpless 2-32? So 2-37, IC 1284. That's where we are. Okay, so we got our guide stars. All looks good. Yeah, that's going to be really pretty. Let's expose that for a while. Let's also give our color what it ought to be, a little bit more neato. Very cool.
And what did Stellarium describe that as?
Oh, I'll show you. It says it's Sharpless 2-37, or
H2 region.
Yeah, it's H2 region, but it's also Reflection Nebula as well, which is very clear. Right here, you can see these beautiful H2 region here with the Reflection Nebula here. This is all dark dust in here, guys, so these bright stars, there's not enough hydrogen to ionize for these bright stars, so the red glow isn't as prominent here because there's not a whole lot of hydrogen here compared to dark dust. So the stars, light is hitting the dust, and the dust is scattering the blue light in the spectrum of the stars. That's what happens. High frequency light is easily scattered by things. And so particles, molecules, our atmosphere does it. That's why the sky's blue. So we see a lot of that, you know. So in this particular case, we have a beautiful hydrogen 2 region, which is an ionized hydrogen region. That's the reddish cloud here. And I'm going to show you that to you just a little bit brighter. Here we go. I'm going to drag this over, intersect our curves a little brighter, and you'll see a little more detail. Okay, and I'll pull this one in. It's going to look a little brighter, and then I'll have to modify that left side again and just pull it in just a little more. There we go. Okay. Look at that. So that's really cool. I like that. That's really nice. That's neat. So we'll let that ride for a bit and see what we get. I suspect it's going to be really pretty.
Uh-huh.
You know, we are using the new camera, and the new camera does tend to show more detail. Oh boy, does it. We've been seeing that in our processing of imagery. I've got more things to do when I go out there in November. Next month, I will be doing a set of stable dark frames, for those of you that know. Because right now, I'm doing a flat frame correction, but I'm not doing a dark frame correction. So the dark frame is going to get rid of inherent camera noise that we get with all the cameras. Hey, Jessica. Z-Bike, how you doing?
May I make a suggestion?
Yes.
When you do the dark frame things?
Yep.
If possible, maybe try it with both the dew shield on and off. See if you see a difference.
Well, it's kind of a process to get that dew shield off, but that's not a bad idea.
I think I mentioned to you recently that I saw a cloudy night or someplace. They talked about dew shields causing vignetting.
Yeah.
And perhaps, removing the dew shield just to shoot the dark frames or whatever might make a difference there.
Yeah. No, I can try that. I've cut this down, okay, way down here, because I want to show you this thing right here. Okay, there's an object right in here that we're going to just focus in on right now. Look at this. Look at that dark globule that is right here in this area, and it's separated from the rest. This is known as a Bach globule, and it's an area where dust and gas has been self-collapsing due to its own gravity. And as it does so, it gets very warm in the center. In fact, it can get quite hot. And if it gets quite hot, then we might end up with a new star formed in the middle of it if there's enough hydrogen in there. But there's something else weird that we know happens, and that is that planets can form. Sometimes they can form without the stars. Those are called rogue planets. Rogue planets are also planets that were once in a system with a star and got ejected through some properties. But I know that rogue planets can also be on their own because that's the way they formed. But because they typically hang on a minute. Izabela says, "Is this a clock ticking here in the stream? It's an illusion." You're hearing the music, Izabela. Hear this? I think you're hearing the music. Okay. So my mistake there, but I do believe we're looking at the music. All right. So anyway, I'm listening to it. Thanks, Darrell. You wanted anything else you want to criticize tonight, or shall I just shut you right off and unshare your screen?
I'll leave right now.
Well, you can if you wish. All right, let's see if we can get this working. There we go.
I have a question I've doubtless asked before.
Sure.
For your Bach globule there.
Yeah.
Are Bach globules and Herbig-Haro objects, I know you differentiate between the two. What is the difference, and is it like a continuum from one to the other?
I would imagine that if a star is forming in a dark nebula like this, that you would eventually be able to classify it as something different. When the star is forming, before it actually winks on its nuclear fusion, well, then we could call it a Herbig-Haro object, right? Because then it's just a hot protostar prior to nuclear fusion, but while it's still young and it's undergoing this rotation and accretion, it might shoot off these gas jets at the poles, and those might be ionized by the heat of such a process. Remember, you can have heat rising up several million degrees and there's no fusion taking place, right? It has to be, in terms of Kelvin, it has to be 13 million Kelvin for the first fusion threshold to take place. And then without that, then you just don't have fusion, but you do have the ionization potential, So maybe these two are related. Maybe Bach globules lead to Herbig-Haros. It would seem logical to me, anyway. Now, Herbig Haros are, in fact, objects we see that have these really interesting jets, as I told you, that come out of the north and south pole of the young protostar prior to its becoming a real star. And undoubtedly, they were in a Bach globule. They might have been formed in a Bach globule. Not all, but some most likely have been. So because the universe takes so long to do its work, we don't get to see all of that, right? We don't get to see when that happens.
So you're saying Bach globule is a protostar. Herbig Haro is a star that has undergone fusion?
No. A Herbig Haro is not undergoing fusion. A Bach globule may not even be a star yet. It might be collapsing. They might have a hot mass in the center. James Webb could certainly show any masses in there, including any planetary bodies in far-flung orbits. But the Herbig Haro object is that next step where we have hot, young pre-stars prior to them undergoing fusion. So globules, no fusion at all. Herbig Haros, no fusion at all either. But they're hotter by far, and they do things that are really strange, like shoot those jets out. Yeah.
I remember we talked about that Herbig Haro object in that cool web image the other day.
Yes, we did.
Remember we called it a protostar.
That's correct. It was a protostar. It wasn't undergoing fusion yet. It was just at that pre-stage where it's just doing things to the interstellar medium around it, like ionizing jets of material it was sending off. But it certainly wasn't fusing yet. Look at this. This is starting to show some beautiful separation in here. There's some really cool stuff going on in here.
Z-Bike asks, what is the distance to this object?
I do not know. Let's go look. It's going to be a few thousand light years, though. It says it's 2,185 light years here.
Okay.
And the object we're talking about is the red cloud object. The blue cloud object might be a little closer to us or a little farther away. Most likely relatively similar distances. Maybe not that much difference, but maybe so. We can find out. They might actually have the separate indications for these. All right, so let's go check it out. Let's zoom in, and let's go to NGC 6595 and see if they have a distance. And they don't. Yeah, they don't. How about this one? They don't have one for this either. So we don't know the distance. How about this? Yeah, we don't have the distance to these objects that are causing the blue reflection nebula. Look how beautiful this is. Very cool.
Very nice.
This is Sharpless. So Sharpless is a catalog name, and Sharpless 2-34. Let's go see. It's IC 1284, or IC is another catalog name known as the Index catalog, and you have a C catalog. It's Caldwell. You have a B catalog. That's Barnard. That's the dark nebula objects. Like this string of dark nebula right here could possibly be a Barnard object in the Barnard catalog. But this is IC 1285 or Sharpless 2-37. Right, and it's going to be an H2 region, and we designate that as H with 2 capital I's. H2, Roman numeral 2. So we've got 28 frames here. We're going to be done with this. This is good. If you look
H2 region implying that it's a stellar nursery, so to speak?
Yeah, and see, that's the thing, many stellar nurseries are undergoing star formation, and so they are creating stars actively, but there's other clouds of hydrogen gas that are no longer doing that or are now too diffuse to do that. particularly when you look at the Gamma Cygni Nebula, it's got a large swath of diffuse red nebula. That's ionized hydrogen, but it's not necessarily a stellar nursery. It's a large swath of this hydrogen gas that's not really doing much of anything except being ionized by nearby stars. It's not self-condensing. It's not actively forming stars in its middle, because there is not necessarily any middle. Okay, 30 done here. We got that. Yeah, we'll save it. And then save it exactly as seen. Actually, I have this image right on my wall right here to my left. So I really like that Bach globule in here. It's really silhouetted nicely. Let's take a look at it one more time. Look at that. You got some really interesting detail in it too. It might be, that globule might be a light year and a half across overall, maybe a little less, based on the distance. I mean, this distance here, it said was like just over 2,100 light years, so that's going to be fairly small. It might be under a light year at that point, and that's pretty cool. Hello, Vince Giglio. How are you? Nice to see you. Sam S is with us now. Nice to see you as well. Very cool. And Rascally Rabbit, haven't seen you in a while. Michael Galea, good to see you. Z-Bike, I think, was happy with the answer. He said, nice. Okay, we've saved this. We'll save it one more time, because I always save one more time if we can. And then we'll get rid of this. Let's get rid of the stack and go back to our night vision mode here in a moment. And this night vision mode will allow us to see what we're going to do next. And we'll bring up our planetarium view. You'll see that where the telescope is really angled over here, that's because we're actually facing very deep into the west. And so while we're here, I was talking about H2 regions that may have actually stopped doing star formation, and we're going to look at one such place right now. This is a nebula that, as a kid, when I grew up, I would look at it, and you call it the duck decoy, other people call it the check mark. It's called the Omega Nebula, Messier 17. And Messier 17 is a fascinating location because it used to be an area that was indeed a prolific stellar nursery. However, it doesn't appear from the research that there's a lot of star formation going on here. And that was research done maybe 3 years ago. So if that's changed, I'd like to know. But, so maybe someone can look that up if they want to. All right, but we'll do this as a 25-second shot. All right, once we're guiding. Okay, we're guiding. Okay, let's go. Off we go. We'll come out of night vision mode and go into stack mode, and we'll have our last buffer with our last image that we just took of the sharpless object. And then look at that. Wow. That's really going to look beautiful. I can see modeling in this cloud structure here.
Pardon me, what did you want to know about the Omega?
I wanted to know because research a couple years ago suggested that it's no undergoing star formation anymore. And I just wanted to see if that was still true. Okay, I have to clear this because we're getting wind out there. So that's what I wanted to know about the Omega Nebula, Messier 17. Is Messier 17 still producing prolific stars?
Give me a minute.
Yeah, look it up if you can. I know, like I said, I read one paper that said it appears that it's no longer producing lots of stars anymore. But I don't know if that actually makes sense to me. Okay. So there's the Omega Nebula. Look at that. See all this hydrogen gas out here that's being ionized by hot stars around this region. Nebulae have a lifespan. They're illuminated hydrogen, and the young hot stars in that gas cloud, they push out with their stellar winds so powerfully that they would blow away a lot of the dust and gas that could be used to make more stars. And in the case of, say, the Rosette Nebula, that's very obvious because the Rosette looks like a donut with a hole in the middle. And that hole in the middle is because the hot young cluster has been literally pushing all that material out, making a cavity around the young cluster. And as it pushes that material away, it can make a compression of that stuff on the outside where it can make more stars, or maybe it doesn't. And so I don't know directly whether the Omega is still doing that.
Closest thing I see is talking about the cluster in the nebula. It's one of the youngest clusters known, with an age of just 1 million years.
Okay.
It's O and B stars. I wouldn't be surprised if they're still making new stars.
Yeah.
If you look at the, are you there?
Yeah, I'm here.
Oh, okay. If you look at the very rightmost portion of the nebula,
Right in here.
yes, the loop shape, which is the neck and head of the swan or the duck,
Right.
Makes kind of a horseshoe shape.
Right.
That's where the Omega is. Greek letter Omega.
Yep. Okay, 1 second here. All right. Agreed. But you can see very clearly that there's something still going on. But it's interesting because like I said, there's a lifetime to these. They don't live forever. They will, in fact, push away all their material at some point, and the stars will start to migrate away. And when that happens, well, then we lose the illumination capability, because the distance away from a hot star is crucial for ionizing this radiation. But the further away it gets, the less ionization can take place. And like what I'm doing here is I'm actually dimming this down a bit so we can see into this. I see we have just a little of our star walking here because it wasn't a perfect image. I'm going to clear it. I hate to do that to you, but we got another one coming up momentarily, and it should be perfect with nice round stars. Nope, that one's also got a little drippy thing going on. Yeah, and so what happens, guys, is that we get some wind and it bounces us around, and the system can't figure out what to do with it. So we just work around that, that's all. Yeah, see, it's still doing it. All right, so let's go down to 20 seconds just to keep the timing low so we can just get our image, and once it starts coming in, we'll actually see these numbers over here are very important. See, it goes to 4.6, 4.9, and then it says searching. So the wind is blowing it around, so this will be out of perfect roundness as well. Not that bad, actually. I'm going to keep it. So, this is what happens in this nebula. So, it may be done, it may not be done. But if it was happening, it's going to happen in here. That's where it'll be happening. Alright, and if we zoom out a little bit, alright, and we process it to where it wants to be, you can see there's a lot more in this region. Right? And that's definitely true. There's a lot more in this region. So we tend to process this white line. You see red, green, and blue. Those are the 3 different color sensitivities for the camera. The average is this white line. So we actually work to that white line. And if I move the dark over, when I get to the peak, that's the darkest the background can get before we start removing some of the important stuff in the nebula. Okay? And we tend to go just to the left of the peak. Alright? So we can actually catch some of the more fainter stuff out here. But look at how much stuff is out there. Alright? And we can go over to this other histogram over there that you see. These are called histograms. And I could actually increase the sensitivity there to kind of show even more what's out there. Look at that. There's so much going on out here. So that's a lot of diffuse hydrogen that's being ionized. Right? Not necessarily making stars, but being ionized. Very nice.
The wiki article makes some interesting comparisons between the Omega Nebula and the Great Nebula in Orion.
Okay.
Omega is 5,000 to 6,000 light years from Earth, so it's maybe 4 times as far away as Orion is.
Mm-hmm.
Let's see. It's considered one of the brightest, most massive star-forming regions of the galaxy. Its local geometry is similar to the Orion Nebula, except that we see this edge on rather than face on as we do with Orion.
Mm-hmm.
So it'd be interesting if you could see this, tipped over so we could see it face on.
From up there, or from down here, yeah.
So if this was as close as Orion Nebula is, this would be
fill the sky.
Side, I bet.
Yeah, it'd be pretty giant in the sky. If you think about it, there are places in the galaxy where you could go where you're going to see objects that fill your sky, without a doubt. But we're not able to travel that way, not yet.
Not yet.
Now, see all these filaments in here, this convoluted filaments you see in there? These filaments are all powered by the stellar wind from this star. So when you look at this filament right here that's coming down, see that? That filament right there, that's powered in part by the stellar winds that are blowing from the stars in this nebula. And a lot of that is shaped from the previous shock waves from supernovas, young star formation, stellar winds. And so when we see this, you got to keep in mind that there's a lot of processes that go into making what you see in a nebula. All the wisps are from stellar winds usually. And in Orion's case, when we look at Orion Nebula later in the season, okay, we'll see a tremendous display of oxygen that's been ionized, the greenish blue oxygen. We'll see the ionized hydrogen, red, and we'll see that mixed in with each other as well, making it almost look magenta when the blue and the red are together and mixed together. So you'll see light mixing, light color mixing as well. So there's a lot very interesting happenings going on out there that we'll check out. And this is one place. That's a beautiful nebula. I used to just kind of gloss over this nebula in the past because it was like, it's just the Omega Nebula. And then when I started taking images and realized just how much is going on, look at this beautiful little density up there. Maybe from a supernova shock wave. Okay, maybe this concentration is part of this is a black nebula, dark nebula that is up here, and the nebula is back here. The shining thing is behind it, and so this is a blocker. This is closer to us than these two sides. These two sides might be totally connected together, but you can't see it because this is blocking it. You know? UFO Bro asked the question. He says, I have a question, and that's why can't we capture meteors? And is it because they are traveling too fast? Well, no, it's actually because if we're exposing an image, the likelihood that a meteor is going to pass through our field of view is very low. It's happened to me. I've seen it before. And in our earlier streams, we've caught it. But it's very rare because it's a big sky. And there's no guarantee you're going to get a meteor flying through the field. Although, as Darrell knows, and some of you know, we did a lunar eclipse in 2019, and while the moon was blood red, we saw a white flash on the moon, and that was a meteor hitting the moon. And we were only one of 5 groups on the entire planet that caught it, and it's in our channel. So you go to skytourlive.org and go to our SkyTour live stream with Marc D'Antonio, and go back to 2019. It'll tell you it's titled "Meteor Hitting the Moon," and it gives you the timing so you can actually go watch it yourself. Because we captured all of it. Yes, Jessica. What's that?
We didn't even catch it at the time. Somebody came in and told us later, and we went back and looked it up.
I saw it, and I thought it was a video artifact. We didn't expect it to happen. And then we were really surprised to find out that it was actually a meteor. So, really cool. Okay. All right, let's save this after 22.
Can we zoom in on it a bit before we leave it?
Yes, we can.
I'd be curious about the whorls and stuff there in the left side, the upper left, or all of it. But
yeah, like that.
Yes.
Our stars are just a little bit elongated because we have some wind out there, but it's not enough to ruin this entirely. So let's put it where it likes to be. This is where it wants to be. And I don't like that. Let's darken this up. Add some contrast. And let's take this way down. And there you go.
Yeah. If you look there over on the right side, there's a narrow V shape, a bright narrow V, just in the body of the duck. Right there, right there, right there.
Yeah.
Right there.
Yep.
That right there. See that V shape?
This shape here? Or this shape?
The narrow V shape.
Well,
your pointer's right on it.
Yeah, okay.
Right there.
All right.
See that?
I do. You know, it's interesting, guys, if you were to fly a spaceship through there, you might fly through there and never even know you flew through a nebula. Because on Earth, you know, when you look at a cloud, you fly through it with a plane, you can see that you're in the cloud, but it looks sharp and well-defined until you fly into it. Then it's all it's all very thin, but still there's 10 to the 19th atoms per cubic centimeter in that. Okay, but out in space, these nebulae have between 30 and 30,000 atoms or nuclei per cubic centimeter. So it's called rarefied, meaning it's very, very thin. But from a distance, you can see all this detail. Look at all this detail. We got a lot in here tonight. And PG is here. Hello, PG. That's Petita in Pennsylvania. That's Pennsylvania Petita. All right. Okay, we'll just let this last exposure come in, and then we'll move on. That's really pretty. In spite of the not quite round stars. Okay, so we'll come out of this and go to our next item here. Alright, so this view that I have here approximates what you'd see in like a small telescope. That's the approximation I've got here right now. This is the main body of it that you'd catch, and other than that you wouldn't really see too much. Alright, so now let's go and just move up slightly farther north, and let's go to this guy and do a short stint over here. This is the Pillars of Creation. They never cease to impress. Here they are. See, there they are. Alright. Alright, now we're gonna wait for our telescope to come back. There we are. We got a satellite passing through here. We're gonna move south a little bit. We're gonna move west a little bit. Oh yeah. This is Messier 16, known as the Eagle Nebula. There's a feature in it that, as I mentioned, was called the Pillars of Creation. You can even see them here, but we're going to do a exposure of 25 seconds. Alright, now that we're going to start up here, I'm going to watch the guiding process and make sure those numbers stay fairly low. If they start going over 1.5 to 2 into higher numbers, that's a problem. Okay, so it looks like we're good, so we can start our exposure. So we go into our live stack here, get rid of the last one, beautiful Omega Nebula, and this is actually under process. We just did that to show, and this is really what's there. And that's up on the server probably by now. And for those of you that saw the beginning video, that song was written, it's the SkyTour live stream theme, and it was done by Rebecca Renfro Borneman down in Florida. And that video was put together by our only one and only Izabela here in the chat. So show her some love for that. She did a really fine job on it. Alright, so we had the whole song, The Universe is Calling You by Rebecca Renfro Borneman. And we had Izabela put it together. So
she did a great job.
She really did. It was stunning. You know. So thank you, Izabela. So there's the pillars right there. You can see them. Alright. And I'm going to try to bring out some more detail. So I'm going to darken up our background by moving that black level over there. And then even though we only have 3 stacked, I'm going to pull this down right there. Okay, now let's pop in here and let's go look inside. Oh yeah, we're getting a lot more detail tonight than we did the other night. And you can see this detail on top of here. It'll come out. And here is the fairy over here. This is another feature that actually it went unnoticed by me anyway. I was just looking at the pillars of creation. But these are really interesting. They're actually dust spires that also have hydrogen gas in them. This is a young cluster. You'll notice the spires are pointing toward the cluster. These spires are pointing toward the cluster. Why is that? It's because remember the Bach globules I talked about? Well, the material at the front end of these blobs is probably where that gravitationally condensing material is sort of concentrated. So when the stream of radiation hits that dust, it doesn't get to what's behind it. All right? So it ends up leaving a long stalk as it shears away all this material on the outside of that density, but not in the middle, because that stuff is being protected by that ball at the front. You know, and it's going to go straight back. It's not going to be like air that curls around things or water that moves around to the backside of an island. You know, if it's hitting the right side of the island with force, it can also swirl around and whack the backside of the island with more force. That's not what we're seeing here, because this is space. That stuff doesn't happen out in space, because there's nothing to cause it to do that. And we mentioned Bach globules, and of course there's one right here. This is a beautiful Bach globule. It's actually it's got hydrogen gas in it that's actually being ionized, and it's a dark dust cloud as well. And within this dark dust cloud, who knows what's forming in there? Could be a star, could be a star system, and that's that, right? If it winks on, there'll be a new star in this cluster.
There you go. Looks like it's lit on the edges all the way around, then dark in the middle.
Yeah, it is. Yeah.
I assume the dark is just the part facing us.
Yeah, or you know, again, the universe can fool us. You know, there's another one here, and we're seeing it fully illuminated. This might just be a hydrogen gas concentration here. You know, let's take this down even more and bring it way here. Let's see what this does. Yeah, look at that. See the details now on the top of here? All the detail that's up here. Now that's what's nice about our camera. It has what's called high dynamic range. We can actually bring this down to almost nothing, all right? And there's still plenty of data that it captured, and it doesn't go down to be like overexposed or underexposed. Look at that. So we can go all the way to here. What were you going to say?
Nothing. I see what you did.
Yeah. And then when we come back, all right, I can actually have it decide where it wants to be. And you can see that where the processing program wants to be is a totally different place than where we want to be. But what's good about it is that we can back out and get a view of the entire region this way. And then you can see all of the nebula that's associated with this region. Look at that. Look at all that. It really is pretty. And then, and when I look here, I just see all kinds of stellar physics going on, and I think of it in terms of, you know, how long it'll be before we see some new stars in there or what have you. And then we can come back in and focus now on the fairy up here, the pillars of creation here, these beautiful block globules. Now you see this one has even more detail in it than when we looked at it moments ago. So this is interesting. This shows some really cool detail now. Oh yeah. Very pretty. Really, really nice. Okay, this is 15 exposures that have been stacked. So I would say we're pretty good with that. And we'll go to 16 and we'll save it now after I name it. This is the Eagle Nebula. And we call it Measure 16. Yep.
Before we leave, can we go up into that upper dark part there?
Yeah, by the ferry?
To the upper right of the ferry.
Okay, let me just pop in the name there. There we go.
And maybe change your settings a little bit. See if, that whole area there, and maybe see if you can pull a little bit more out of it.
Yeah, we had a satellite rip through here, so there's a trail that's slowly disappearing. But let's start with what it wants to be at, and that's going to be too bright. All right. Okay, so we want to zoom out a little bit and come down here. Let's see if we can just pull out, soften everything up this way. And let's go this way, just initially. Now, when we process these images, one of the very first things we do is we actually remove all the stars. And we just process the nebulae. And at one point, I'll actually show that to you. I think this is a very, very interesting and fascinating process that we go through. Maybe one night we'll just have a processing stream where we do processing. Z-Bike says, the pillars of creation were made famous when NASA's Hubble Space Telescope captured them. Absolutely correct. They are beautiful, and they have been totally revamped with the new James Webb Space Telescope views in the near-infrared and the mid-infrared cameras, showing all of the dust and almost leaving out any of the ionized hydrogen. So it's really, really interesting. So yeah, there's the region.
Yeah, there's so much going on in there, and
I know it, huh?
All the streaks and whorls and stuff.
Yeah.
And that whole upper big dark area there at the upper right, just under that red cloud. It's very tangled.
Yes. Let's pull this over a little, and let's try this.
Cosmic ray, the pillars were discovered by a ground-based telescope. It's the Eagle Nebula. They just didn't call it the pillars back then. Astronomers had known about Messier 16 for a couple hundred years.
Yeah. Look at that.
Somebody at NASA just dreamed up the name Pillars of Creation. Historically, it's known as the Eagle Nebula.
Yeah, and even before they called it the Pillars of Creation, I was saying that dark nebula is literally fundamental to all life in the universe. And this is dark nebula with hydrogen gas that's been ionized, and the dark nebula is standing out with the mixture of hydrogen throughout the whole region. You know, the ferry is interesting too over here, Darrell.
Oh, yeah.
Looks like it has a spine of dark nebula and hydrogen around it.
Yeah.
Again, you could see how these hot young stars might be ablating this and causing it to vaporize and blow backwards,
Yeah.
you know, while ionizing it at the same time.
I'd be curious to see that in 3D. The darkest part of the fairy there on the right, you know, it looks like it's probably in front of everything else we see there.
It does look that way.
Yeah. I don't necessarily see a fairy. That's what they call it, though. I've said before, it looks like a hood ornament or almost like an Academy Award statue to me, an Emmy or whatever they call it.
Yeah, it could also be like a when you said hood ornament the other night, I think I said, no, it's like a jaguar hood ornament.
Yeah.
Yeah. Hey, Robin Curtis, how are you? That's Robin. All right. Then we'll do a processing stream at some point, Robin. Rob, we got to get back on the database, too.
The pillars, Ray, are the eagle. And again, I mean, the eagle's been known of for, well, since the 1700s.
Yeah. Messier 16. Charles Messier saw it.
Yep.
Hey, old schoolie, how you doing, man? I talked about the age of the universe on another radio show last night besides our own. I was on Night Dreams Radio, and I was asked a question about the finding that the universe might be a lot older. And actually, the data is not in fully, but I'll tell you how that works. When you look at everything in the universe, we figure out, we back engineer how it formed, approximately how long it might take. When we look at galaxies, we figure they have to be in process for like almost 1 billion years before they start to show any definitive detail. However, in looking with the James Webb Space Telescope, we could look back and see galaxies literally just about 500 million years after they started forming. And what we see is, in some cases, fully formed galaxies. And that just doesn't work with our cosmology. That's not what we thought. So that gave rise to what you just said, that maybe the universe is a lot older. And we don't understand the Big Bang. And maybe the Big Bang didn't happen the way we thought it did. So it was actually both an argument against the Big Bang and an argument against our understanding of the age of the universe. In subsequent experiments, though, the James Webb actually verified the Big Bang. So we've got two schools of thought. And the one school of thought says that the universe was created by a Big Bang and that galaxies formed quicker than we thought. And the other is that there was no Big Bang the way we understand it, and galaxies have been here for up to 24 billion years. And right now it looks like there's evidence for both. However, the nail in the coffin saying that the Big Bang did occur has been nailed, okay? So it looks like it did occur, but now maybe our cosmology is not quite up to snuff. So the James Webb started looking at other galaxies, and all it found is more problems, because I mentioned early on in our broadcast tonight, it found other elliptical galaxies, all right? And these elliptical galaxies, this is so beautiful, are other elliptical galaxies that found under the James Webb's infrared eyes. You could see that it had spiral structure in it that wasn't evident with visual light that we see with our eyes. So clearly something's up, and we don't understand it yet, but it is very interesting. And I think that time will tell, and we'll certainly have a better understanding of our universe in just a few years. And James Webb is responsible for opening our eyes, literally, to the beginning of the universe. So I hope that was a good answer. One that you
Did
understood.
you see that Kurzgesagt video I posted in our group chat earlier today?
I didn't watch it.
Oh, you might find that interesting. Kurzgesagt's that science channel that has the cute cartoons. They really talk about some interesting subject. This new one makes an interesting point. They're talking about life in the universe.
Okay.
And they speculate that it may go back nearly to the beginning of the universe. They made an interesting point that after the Big Bang, the universe started cooling off. And at one point, after the formation and supernovas of the first stars ever born, to help seed the universe with its first heavier elements, that there was a point in time that the universe, most of the universe, was at that Goldilocks zone temperature, between fire and ice, so to speak. And that, I called it panspermia, and Izabela kind of disagreed with me on that, but that life could have got its start out in the universe much, much earlier than we thought. And it's a really fascinating video, I thought.
All right, I'll have to watch it. I know that panspermia is actually not that far-fetched when you think about it. The early solar system might have had life on other bodies, such as Mars. Mars had a much thicker atmosphere than it does now. Mars had lots of water, freely running water on Mars. So there could have been microbial life early on Mars. And there was known to be massive strikes on the Martian surface by bodies from space that blew off large chunks of not only atmosphere, but pieces of Mars. Those pieces of Mars have made it here. We've seen Martian meteorites in Antarctica that are on the ice pack down there. So it's not illogical to then suggest that this could have happened back when Mars had more life on it, and maybe some amino acids that were part of a process, an ecosystem of life on Mars, were trapped in a meteorite, as we've seen amino acids brought here, like the Murchison meteorite brought amino acids here from space. So it's possible that panspermia as a real process did occur. Now, it means that if it did occur, it probably seeded life onto our planet, but there was already life going here, so it kind of mixed in and is indistinguishable, in terms of its DNA structure and anything else, because it was probably brought here at a much, much more primitive level. So it's possible panspermia occurred. I just think that it might have occurred differently than the way people tend to think. Living things were seeded here. No, I think that the building blocks of life could have also made it here and helped the process that was already going on Earth. That's just my thought.
Well, the whole point of the video is that at one time, the whole universe was in the Goldilocks zone and much more conducive to the early formation of life in the universe.
Yeah. And it would be important at that time to see if if there was adequate diversity in the elements, like in the periodic table. There would have to be quite a diverse group of elements. Carbon's the fourth most abundant, we know that, in the whole universe. So it stands to reason carbon would be at the forefront. I guess that means I'm a carbon bigot. And Without a doubt, I am. You know.
Well, and one of the points they made was it was, you know, uh, as you said, the age of the oldest galaxies. You know, the galaxies were formed as stars, and the early stars are great big, fast living, fast dying stars.
That's right.
And therefore they seeded the universe with the heavier elements to help life get started.
In
when
fact,
it was warm and more
true.
conducive to life.
Yeah. But
anyway.
No, that's a great idea, a great theory. I love it, actually, and I would love to investigate that more. I would also caution that, yes, that may have happened early on, but where would that life have been? That life would have been near where a supernova went off, because that's where those elements will be. And they would not have distributed themselves. Got it on there. They would not have distributed themselves adequately throughout the universe to areas that are backwaters. They would stay in the areas where supernovas just went off for the time being, and those regions are not conducive to life. Right? I mean, they get hot, ionized for many, many millennia. And so it's possible that they aren't the best locations. And we need time for this stuff to disperse to the quieter backwaters in the universe. That's just a thought. I'll read the article, though. It sounds fascinating.
They have references in the description of the video, I believe.
Okay.
Anyway, what are we going to next?
Oh, I don't know. Let's keep riding up the Milky Way. I would like to check out just like a random location. Remember we did that? And it was a lot of fun.
Uh-huh.
So I'm going to pick this area right here and say, let's just go there. We're just going to go to this little spot because it looks like there might be something here. And we'll find out if there is. It looks like there's more here, though.
Yep, that's when we didn't know what the telescope was pointing at. We just found the dark rift and started following it north. Which
was just so much fun, actually. Because Darrell and I were saying, oh, what is that? Is that the Dark Horse or something? You know, oh, that's not Dark Horse. That's, yeah, there's a lake. That's the Pipe Nebula. You know, that kind of thing. It was fun. So we'll just do a quick 25-second shot here and see if there's anything interesting to see. First things first, I'm going to bring back my machine here. There we go. And so now we're going to be spending the next 14 seconds hunting for a guide star. Okay, there we go. Guide star captured. Underway. And so let's go and see if there's anything interesting here to see. So we'll go into our stack and view our last image of that beautiful nebula, which is now up on skytourlive.org for you to take down. It's a freebie. Actually, I can save it one more time. Oh, maybe not. Okay, so I never saved it, so it's still there. Good. All right. Oh, look at that. Fascinating. There's always something to see out there. We got some dark nebula here, dark cloud here, dark cloud there, a string right there of stuff that's really cool, a filament. So, I mean, it looks like that it doesn't lie. There's really pretty cool stuff there.
Sam S., the Hummingbird Nebula is in Cepheus, which is up this time of year. I don't know if we can see it or not. It looks like it was discovered with a much larger telescope.
The hummingbird, is it a small
hummingbird? I don't really know.
Okay.
I found it listed on Google and
okay.
And checking sources there.
Okay. I don't mean to cut you off, Darrell, but I do want to mention Rebecca Renfro is in our chat. She is the composer and singer of the song that is the SkyTour live stream theme song. Yay! Hello, Rebecca. Welcome.
That Rebecca. I said hi to her. I didn't realize that.
Yep.
Hi, Rebecca. Beautiful song.
She sang and created The Universe Is Calling You. It's a beautiful song. And so she gets to hear her song every time we do a stream. It's wonderful. Welcome, Rebecca. And she says, do we have a favorite section of the universe? Absolutely. And it's just not one. That's the problem. I really enjoy the Orion Milky Way, and I really enjoy the Summer Milky Way for reasons like this. Every one of those points of light is another star that's potentially like the sun. And we could end up seeing millions of life forms in this one view and not even know it. So I think that's pretty cool. So that's for me. That's how I feel about it. So what I'm going to do now is I'm going to go to one other spot that I think is pretty cool. And we're going to first come up here. I didn't save that photo at all, no. Alright, let's go up here. Now, right near Terra Z, is Terra Z got this dark nebula in it? Is that real, or is that just a stellarium pretendo thing? What do you think, Darrell?
I'm not sure I understand your question.
I'm seeing what looks like dark nebula represented here, and I'm wondering if that's just a stellarium artistic thing.
I don't know.
Okay, that's really small. All right, so we're gonna come up here now. Okay, and we're not gonna look at the dumbbell tonight. We're gonna look at something else. All right, we're gonna go check out Albireo. This is a visual.
Mark,
yeah?
Michael H. was asking about Stephan's Quintet.
Okay.
Didn't we try to see that once?
Oh, yeah, we've captured that quite a lot.
Did it show up well?
Yeah.
Okay.
It'll show up very well in this camera, too, actually, with more detail.
Okay, it's in Pegasus. So, if not tonight, sometime soon, maybe we can take a look at it.
All right. There is Albireo, and let's head west a little bit, and we're not even gonna stack this because it's just beautiful seeing it like this. So let's just see the colors as we move it. The colors become evident. Okay, this bottom star is a K3 giant, I think, and this is a B8. So on the OBAF-GKM spectrum, from hottest and bluest to coolest and reddest, the B star here is very, very hot, and the K star is less so. But there we go. There is Albireo, the beautiful visual double. How pretty is that? This is Albireo music too.
Sam, the hummingbird is in Cepheus, which is prime time this time of year. It looks like it's actually very close to the Cave Nebula. which we looked at just the other night, didn't we, Mark?
Yes, we did.
Yeah. Sam says it can be seen in a 10-inch telescope.
All right, well, if it's there, we can try it. I can try looking it up and seeing if it's in the, if it has any other names. I got to pull up probably...
It's a recent discovery, I believe. That guy that does nebula photos on YouTube.
Yeah.
I think he's claiming he found it. It's also known as Carver 1.
Okay.
It looks like a rather dim reflection nebula.
Okay. Look at those colors. Now, this is live, by the way. You notice the image is changing every second because we're doing 1 second intervals here. So this is the K giant star, and this is the B star. And so they're just they form the head or beak or the eye of the swan in Cygnus the Swan. Yeah, just really nice. So that's one of my favorite double stars. Indeed. And then so you back out and you see it gets lost. You almost don't even see it. So we visited it and it was very happy that we did, I'm sure. Okay. Now there's the Tulip Nebula. There's the Crescent Nebula. We've looked at the Crescent. I'd like to look at another segment of the Gamma Cygni Nebula, which is right here. This is a very, really interesting location here.
Mark, excuse me a moment, please.
Sure thing. Okay. We're going to look here because this guy is really interesting because there's a blue reflection nebula in here that I would like us to see. Alright, so here we go. We're heading there. Notice the telescope is moving. Okay. Alright, and let's just go to the night vision mode. There we go. All right. Okay. Now let's go back here. All right. I'm gonna move us a little to the west. There we go. So guys, thank you for joining us tonight. This is a lot of fun. Enjoy your company as we bring you the universe live in real time. I honestly don't think there's anyone that does this. There's other people doing astronomy stuff out there, but doing this, going to different objects, making those available to you, having a whole shop where you can go grab our stuff on blankets and mugs and all kinds of things, and also going to skytourlive.org and being able to get giant prints on your wall, or going there just to see and grab free photographs. I think we're offering quite a lot, you know. So we do have a Patreon. We need we have some wonderful patrons. Okay. These patrons are folks that have spent time with us: John P., Izabela M., Ollie B., Chief McCyber, Vera C., Ronald T., Martin W., Raymond B., Cindy M., Susan W., Diane H., and JSEO 77. These folks are our current list of patrons. We don't have that many. We need a lot more because our internet does cost us quite a bit of money. So hopefully you can join our Patreon, and you can do it as little as $3 a month, $5 a month, I think $25 a month. And you know, we have some people that are give even more. So we do have quite a few tiers. And we're setting it up so you can get some interesting swag for each of those tiers. And we'll make those available and tell you what those are going to be here soon. Right now, let's do a 25-second photo of this region, which looks like just an ordinary star region, right? But when we look at it in detail, you can see something very different. Okay, this is gonna clear. We're gonna clear this out of here and be ready for the next photo. And ready. 1 second to go, and boom, here it comes. Look at that. There's that beautiful reflection nebula I was telling about. See, I don't lie. Look at that. That is going to resolve into a really beautiful region in just a few minutes. Hey, JSEO. Meteor, huh? This is that region with the two reflection nebulae. I can see it. I need to move that up more. So let me just do that. I'm gonna just bring that up more. So let's do that.
This is near Gamma Cygni?
Yes. Yep. Okay. And we're going to just take this and go up here. So we're going to basically go south. Okay. And then we're going to go west. Go west, young man.
Who said that?
I did just now, but I don't know who actually said it.
Horace Greeley said it.
Okay. But Horace Greeley didn't go west. All right.
He was a newspaper man, if I remember right. I could be totally wrong about that.
Sounds familiar.
He was, I believe he was one of the big proponents of Manifest Destiny back in the 1800s.
Okay.
And he said, go west, young man.
Mm-hmm. Now, I've changed the exposure. It's at 25 seconds, but I'm dropping the gain down to 200 from 250. And there's a reason for that. I want to actually get something with a little less noise. Now, the best combination for our camera telescope system is a gain that's at around 150 or 100, and I choose to do it like 200, so a little more noise, but this is good for us. Hello, Simon Thompson. All right, let's see this again. Now this is facing almost straight up, so this is going to be a really, really pretty shot. All right, and here we go. There it is. There are these nebulae, and there's the beautiful hydrogen cloud, and we're going to just give this a little bit of a tweak. We're going to take the color and balance it. Look at that, huh? That's going to resolve into something beautiful. This blue nebula, it looks brushed, like something brushed it. And that'll be very clear here in just a bit. The D'Antonio smear. Cosmic Ray says, I think this image is the D'Antonio smear. Hello, Stella. How are you? Are you in AZ? You're in Arizona as well? Our telescope's in Arizona, and I'm running it from Connecticut, where I live. So I'm always out there. I'm going out there again next month. I was out there a few weeks ago. Hello, railroad engineer. What's going on? He says, we're traveling the universe with Captain Picard. Make it so, number one.
Please hit the like button if you're enjoying the stream.
Yeah, I mean, we do this because we love it, and we'd like to know that you do too. Old School Lee is back. Welcome back.
See, already said goodnight to him.
I know, right? He's back. Stellar says, "Oh, that's so cool. I'm in Arizona. Been following for a while. Always miss the streams. Glad I could pop in today. I am too. I'm very happy you're here. You know, we always love seeing people from Arizona. Where in Arizona are you from? We are actually, the telescope is west of Phoenix by about 70 miles. It's southwest of Wickenburg, out in the Sonoran Desert. You drive 14 miles of dirt roads to get to it. And I do it now, like no tomorrow, you know, whenever I go out there. But I am 2,500 miles from it right now. But we set it up so that we could run it from a distance. That's the whole idea. You know, it's very important to be able to run something like this long distance. So I've done these streams. At conferences around the country, and people would come in at night and they would actually sit down. I had like 200 something people out in Palm Springs. The sky is light polluted as heck, but I was opening up the observatory and we looked at a supernova in a galaxy far, far away. And so they got to see this stuff. It's pretty cool. Here you can see this resolving into that beautiful brushed look.
Looks pretty dark.
What does?
The whole image.
Okay, well, I mean, we can change that. If you want to see what's really there, we can just do this. Okay, you can see now there's a lot going on there. That always overdoes things, so what we do is we bring it down, and then we use these more carefully crafted controls to actually bring this detail out. See that? That looks pretty good. And we can actually darken our background just a little more. There, see that? Look at that. Neat. Let's actually do a color correction as well. And there you go. Izabela says this is a beautiful place I haven't seen before. Yeah, I actually, I have not imaged this very much, so it is clearly a very, very pretty place. Okay, if you look here now in this blue, we're gonna go check it out. We're gonna dive into it. All right, you can see now there's this streakiness and detail going on in here. Look at these streaks. All right. Something is happening in here. Now, as far as what this officially is, I think it's probably a good idea to find our way. Let me get out of that. And get out of that. And come back to where we were. I don't know why we blew way down there all of a sudden, but that's not affecting our photo. We're doing that over there. Okay, this is probably the region of NGC 6914. And it is. Okay. So we're going to call this NGC 6914. This crosshair is where we are. There are the 3 reflection nebulae. And you see there is a dark tendril right here moving through. Really cool. Very nice. NGC stands for New General Catalog. And the New General Catalog has, oh gosh, almost 8,000 entries in it. Or more or less. I can't remember the exact number. I have the full catalog here with photos of everything. But it's really an impressive catalog. And as such, it's also impressive that we also have the index catalog, the AAVSO, the American Association of Variable Star Observers. Have the variable star catalog as well. Because everything's changing in the universe. The universe changes. It's very dynamic. It's just that people aren't used to that. So. Alright, so this object is known as NGC 6914. Here it is. Let's just bring that out of there. And let's get rid of the telescopes for a minute and show you the whole thing. So let me drop that down. There you go. Okay. So put that up there. Really cool. All right, so let's do some noise removal here. There we go, and then let's pull this back just a hair. When I turn on a little detail enhancer, you see that you get a lot more detail in this region. Very cool. Pull you down. Very cool. Okay, nice. So we're just waiting for this to solidify and come in. You can see there's some real neat filamentary structure coming out of this. Let's see if we can punch it up a lot and see what that looks like. Yeah, look at that. There's a lot going on in there.
That's more like it.
Yeah, except
noisy image, but it shows a lot.
But we can actually reduce that noise here by doing this. All right, and now it's still noisy, but we'll be able to see more detail up in these clouds here. Look at that. That is just really stunning. This little beautiful curly Q. Again, shaped by stellar winds and supernovae in the area that have pushed this material all around the universe.
So does this have a particular name, or it's just part of Gamma Cygni Nebula?
This is NGC 6914, actually.
Okay.
Yep. And that's what we're going to save it as, too. NGC 6914 is this H2 region, but it's also includes these beautiful reflection nebulae. And whenever you see reflection nebulae, guys, you are also going to see dark clouds of dust in the region. All right, there's always there are 1-to-1 correlation between what you see there, all right, and the fact that you've got dust around. So it really comes down to this. Okay, these clouds are actually dust that's being in the process of dust is actually scattering the starlight coming to them. These stars, starlight is coming into this dust, and the dust is absorbing the blue and kicking it out in every direction. High frequency stuff. That's what our sky does. The molecules in our sky do the same thing. And these are molecules as well in here, probably molecules of carbon and silicon and some other materials, ices. Okay, but you see, we're seeing the same process here. That blue there is the same exact process as our blue sky here. That's what's cool about it. Now, when you look at stars, you might be tempted to think that if they're bigger dots, that means they're closer to us. Like you might say, oh, that one's closer to us. Actually, unfortunately, the universe doesn't work so simply. I wish it did. But you could actually have this star being like 10 times further than any other star around it. It's just much larger in diameter because stars come in a variety of sizes, right? And the farther away a star is, typically the dimmer it's going to be. But if it's bigger in diameter, that's going to fool you into thinking that it's closer, right? So this star may not be far away, or it might be far away. It can be much further away than any other stars around it, or it could be actually closer to us. We don't know unless we actually know the spectral type of the star, the complete story of what makes that star a star.
All stars, with maybe just one or two exceptions, are basically just point sources of light to us. They're all so far away.
Yes.
You could describe them as literal points of light.
Yeah.
They just some are bright, some are dim. There's a lot more dim ones than there are bright ones.
Yeah, actually, the dimmest red ones are the most prolific stars, the most populous star in the entire universe. All right. Let's bring back the telescope for now. And now, what we're going to do is we have NGC 6914 listed there. And what we're going to do is we're going to save this with these number of captures. And then save it exactly as seen. That's really pretty. And I like what I like about showing this is that there's only one other type of nebula that we don't see in here at the same time, and that is the nebula that results from oxygen ionization, and that's a greenish nebula, right? Like the Dumbbell Nebula. That creates a greenish nebula. Planetary nebulae, stars that have shed their outer layers as they've grown older. This is an example of that as well. Those stars will produce doubly ionized oxygen, and it's a greenish shell around them. Okay, and they're not the only ones that do the greenish shell either. But you know, the universe is limited in color. Believe it or not, it's beautiful. It has all kinds of colors, but they're limited to red, orange, yellow, and blue, indigo, and violet. There's really no other colors. There are no green stars, and that has to do with a process we could talk about at some point if you want to. And that has to do with the fact that black body radiation radiates a certain way, and stars act like black bodies. So they go from blue hot to white hot to yellow hot to red hot. There is no green hot. All right? So that's why we don't see green stars. Okay. So we'll save this now. Save it exactly as we see it.
Sometimes stars can look green. The star Antares in Scorpius has a companion star. It's sometimes described as green, but it's more of a contrast effect. It's not really green.
Yeah, if they look green, it's an illusion of some kind. Yeah, and here, look, we have a green sky. All right, let's take a look at.
Pegasus should be well up. Would you like to try Stefan's quintet?
Sure, why not? Let's try it. Yeah, there it is. Let's see where that is. Okay, and what's the altitude? Oh, it might be ready for us, Darrell. All right, guys, let's try it out. We're going to go see some galaxies. I mean, we could also look at Andromeda and so forth as well.
Can you back out a little bit in Stellarium?
Yeah.
I just want to get a feel for where we are in the sky. Almost
directly overhead.
Yeah.
Okay. I see galaxies in here. I'm going to actually just move a little bit westward here. All right, let's just do a quick 20-second shot. Just to capture. Let's go back to 6914's image that's in our buffer. Check it out for one last look. Look at that, with all the detail around it. Holy cow. Man, that's going to process beautifully. Okay. And let's take a look and see how close we got. Okay.
Set them over by the right edge.
Well, that's the beginning of them. Because Stephen's quintet, is that... Do they actually... Are they all in this one small field, or are they in a larger field of view?
Oh, they're all in a small field.
Okay, so that must be them.
Yes. I think you may need focal length to do it justice.
Yeah, we've got twice the resolution we had with the other camera. And as such, we get more detail, but I think we also need additional focal length, like you say. Yeah, look at that. A tiny cluster of galaxies. But if you're near them, you wouldn't say they were tiny.
If you bumped up the gain a notch.
Yeah, I could, and it makes it more noisy. But we can try this. Yeah, well, there's certain objects that aren't the best for us to view. And that galaxy up there looks rather interesting.
Uh-huh.
Let's go find out what we're looking at there.
Is that the Deerlick group they're talking about there?
That's the galaxy that's right there. It's a SAB.
So wow. This group.
I know, because there's another one right near it.
Yeah, I see that. And actually, when you zoom in, there's a whole group of them.
Yeah. Yeah, Stephen's Quintet is interesting.
I forget who asked for that. I think it was Michael H.
Okay. Well, Michael, we're going to have to forgo it, unfortunately, because it's not giving us the kind of response we want. Maybe if we were to hang out with it a little bit longer. But what I'd like to do is, since we're here, let's actually move up and check out that Deerlick group one. This is right up above it. That'd be fun too. And we'll head west. That's a pretty good sized galaxy. Alrighty. So we're searching for the guide star. We got our guide star. We're starting to guide. And we're going to do a 35-second shot here. There we are. Off we go. And we'll live stack. We'll see our Stephen's Quintet here for just a moment. Interesting. That's a fascinating group of galaxies. We do need a little more focal length, so we'll come back to that with the next telescope we have, because our next one, we already have all the equipment picked out now, and we already have all the cash for it, and we just have to go about getting it. Okay, I'm gonna clear this because we weren't quite ready to go here. The guiding wasn't perfect. These numbers ideally should be under 1, 1.3, 1.5, 1.6 is starting to cascade into the bad realm, but now it's dropping. That's good, actually. And now we'll get our first shot. It'll be pretty well. No, that's good.
That's a nice galaxy.
It is. Yeah. And this is the Deerlick group. And why it would be called a Deerlick group, I don't know. But the occupants of the galaxies probably would say, what kind of a name is that?
I see at least 4 galaxies.
Yeah, we've got 1, 2. Looks like we got something here as well. We got one out there.
There's at least 4 right just to the left of the main galaxy.
Yeah, we've got 1. We've got 2. Looks like we got a 3rd here and a 4th. Maybe another one in here.
There's one just to the left of where you are.
This one?
Yes.
Yes. Well, let's see what we got when we zoom in. Oh, yeah. Without a doubt. Let's drop this down. There we go. So now you see the one here. You see the second one here. See a third one right here. Looks like it. This fourth one. And there's another one up here.
Uh-huh.
Oh, actually, and then a fifth one out here.
Yep.
That's a nice spiral. You can actually see the dust in the dust lanes there. Quite nice.
Let it build up a little bit. I bet that actually shows up nicely.
Yeah. We only got 4 stacked right now. Our background is nice and dark. Let's pull this down even more. Oh yeah, look at it. That's going to be
Big
really
dark
pretty in there.
dust lane.
Yeah. We got this big dust lane here, and we got several small ones here. Now see, with this camera, we can see this detail. With the other camera, we wouldn't have seen this detail. This is the Deerlick group of galaxies, Cosmic Ray, to answer your question. It's in Pegasus. Renee Cruz. Oh my god, you guys are still on? Well, yeah. Hello, Gladys.
There's at least 2 dark dust lanes on to the right of the nucleus.
Yeah,
and,
see one there and one there.
Yeah, and
zoom in even more.
kind of a dim hook of like a spiral arm above it at about 12 o'clock.
Then we got one down here.
Kind of a hook shape to it.
Yeah. Wow.
The one at the bottom actually extends quite a ways.
It does, yeah. This galaxy is showing some interesting detail in it as well. Now keep in mind, guys, that all the stars you see here, these are here in our galaxy. Those galaxies are way, way out there. You don't see the individual stars in those galaxies. Alright, let's back out just a tad. And let's do one thing here. I want to reduce this brightness a little. Excuse me. Okay, we'll bring it back. There we go. That's pretty. It's only 9 exposures too.
Spiral arm at 6 o'clock or so. Looks like it extends quite a bit farther than the one at 12 o'clock.
Yeah.
I actually see several faint tendrils, for want of a better word, in the one on the south side.
Yeah, like here.
Yeah, I see at least 3.
Yeah. Let's see if we can bring those out a little bit by pulling this in. Makes it more noisy, but at least we'll see the detail if it's there. There we go.
Oh, yeah. Yeah. You can see that hook in the upper one.
Yeah, let's do this.
hooks to the left, and a lot of mottling in the dark lanes on the right side of the galaxy, right side of the nucleus.
Yeah.
One dark lane just immediately to the right of the nucleus, and a great big dark lane next one over to the right, and a little bit more of like a spiral arm outside the big dark arm.
Yeah.
Dark cloud.
Let's just check something out here. Alright, so this is NGC 7331, this galaxy. And then these are the galaxies. And this one, it shows a distance of 53 million light years. I would assume these others are smaller and more distant.
Might be satellites. At least a couple of them look like spirals, though.
Yeah.
Maybe. And the stellarium clearly shows at 3 o'clock is stellarium, what we saw at 6 o'clock in the image.
Yeah.
You can see like 3 bright fingers in that spiral arm.
Yeah.
Over at 3 o'clock, and that faint bit of bright galaxy above the big dark bar.
Yeah, so this, we're not getting a distance on any of these, but they do look like they're further away. Cosmic Ray suggested that this is a foreground galaxy to this cluster here. So he could be right about that.
Marianne is here. Hello, Marianne.
Hey, Marianne. Marianne just did a talk tonight with Dave Rich for UAP PD, her organization with Dave. Police officers who hear strange stories of unknown origin, like UFOs, paranormal activity, things like that. How'd it go, Marianne? Just let us know. I won't bring her in because she's been talking for an hour or two. These spiral arms are really nice. Look at this beautiful greenish blue segment here. Maybe that's a OB association in here. There are spiral arms, dark lane. Look at that.
It's interesting dark area just below that.
Yeah.
Kind of it's got several little arms in it.
Yeah. Yeah, you can see there's a lot going on in there. Very cool. Well, let's go to 18 here and save this. This is an example of a very far away galaxy relative to a galaxy like the Andromeda Galaxy, which, by the way, is kind of nearby. Alright, so night mode, and now let's go and go back to here.
That was a nice bit of serendipity there. That looked better than Stefan's quintet did.
Yeah, we had some nice involvement there with those spiral arms. We'll be able to actually make heads or tails of those even better when we actually get this processed more. Okay. Don't know what this is. It's probably a sharpless item. So I'm going to go here and just check it out. Looks like a dust cloud with some reflection nebula. Kind of like those weird things. Alright, let's go down to 25%. Okay, there we are. And go back to this. That's what I thought. We'll go there and do that. So now should be right in this now. This reel. Let's try it. I don't know if it is though. We're gonna find out. I may have to move. That is amplifier noise, and that's what the dark frames will totally remove. We'll be able to just take that right out. Yeah, Jordan Pease is fantastic. Okay, let's see where we are here. Oh, I think we might not have gotten it. Okay, first things first. Let's do this. We're gonna back out of here, and I'm gonna go back to this galaxy for a second. Alright. And I'm doing that for a reason. Because I'm going to synchronize. I see it right there. I did get it. Well, that's alright. It's dim.
Looks on Stellarium like it needed to scoot over to the left a little bit.
Well, I think that was a star that had a halo around it. But we'll check it out. Alright, let's just do a 10-second shot. This is just to... Oh, there it is right there. Never mind. Alright. Alright, never mind. There's our galaxy, so we're going to head to the west. I have a little something to do, and that has to do with this. We're going to align the telescope perfectly so that wherever we go, there we are. Okay. Okay, let's drop this down. That's quite a pronounced drop down. There we go. And just click over west. And one more click north. And one more click west. Alright, and then we come back to our stellarium. And now we center on that. And what we do now is we tell this that the center is where that is, because that's where we're looking at. We're looking right at it. So we're going to move this over there. And now we are perfectly aligned. And now, if we go back to this guy again, if I select anything in there and just say go there, it's going to go directly to that spot. There we go. There we are. All right.
Looks like a shaggy dog.
Doesn't it? So, once we get our self-guiding here, which we're doing, I'm going to try a 35-second exposure, and I am going to kick up this to 250. All right. Not 35 milliseconds, 35 seconds. Okay. Very good. Off we go. So you guys are coming in with us on an exploration of the universe. It's amazing how many stars are out there. Right. So when this comes in, we should start to see the nebula. There it is, right there, and there's something there. Let's do that. Let's process a little. There's the cloud. You can just start to see it. Now, remember I talked about stacking and how it brings detail to the top. That's exactly what's happening here, because all around us here, there's noise, all right? And as we stack images on top of each other, even the subtle brown clouds will start to stand out as data, because they don't change. They stay there. The noise is random and changes every shot. I have heard a ghost calling that 911 number. That's correct, Marianne. Or something did. Being a science guy, I always try to figure it out. Unidentified S4, what's going on? Nice to see you. This is a really interesting object as it's starting to show.
Looks like Ray says it's Lens Bright Nebula 435.
Yeah, I don't have the lens object up.
Yeah, I know it just said star when you clicked on it.
Oh, yeah.
And there's actually a little faint fuzzy to the upper right of it.
Yeah. You mean this here?
That might be a galaxy.
It is.
Yeah.
It's a distant galaxy, as this is, too.
Yep.
Yep.
Oh, I know there's lots of galaxies in Pegasus.
Yeah.
I think there's a supercluster in Pegasus, isn't there?
Oh, I think so. Yes, indeed. I'm not sure what to call this. Let's see what else is there. It's Linz.
Go turn on.
Linz Nebula.
Yeah.
Yeah. Let me turn that on Linz and then. All right. So now we come in here and go to our DSOs, which stands for Deep Space Objects. We'll turn on Barnard, Sharpless, Linz Dark Nebula, and Linz Bright Nebula. So I'm guessing that's an LDN, Linz Dark Nebula. No, it says Linz Bright Nebula. Look at that. Interesting. Well, that's what it looks like.
Let's say 438.
I do believe it did.
They said 435.
That's 438. 435 is up here. Interesting.
Actually getting a little bit of a halo around that bright star to the lower right.
Yeah, we are.
I know it seems like the halos went away in large part with the new camera.
But we're really pushing right now.
Yeah.
Okay, so if I take this down, now we
Michael,
can...
I have a question for you.
Our sun in a region this dense with stars. Is our sun in a region this dense with stars, or are we much less populated here? Actually, that's a very good question. We're actually kind of in the suburbs relative to the galaxy. So our sun has long ago left the cradle, the location where it was formed, and drifted out into the galaxy. And we have found one of our stellar siblings so far, which is a star that's exactly the same composition as our sun. Same, you look at it and you'll see the same spectrum as our sun, and that's like a fingerprint. Only if the stars were formed with each other will you actually see that. And ours was formed with others, and we've only found one so far, a stellar sibling so far. We can't see it from here because I think it's in the southern hemisphere. Mr. Django, how's it going over in Belgium? Good to see you. This one isn't coming out so bright. I may abandon it. Go to something brighter. Yeah. Okay, we're going to abandon this one and go to a brighter one that's out there. Okay, so let's do this again. And our night vision mode. Now we come back to our stellar searchy. Let's take a look. We could come down here. And what's this one? Is this 7822? Oh, it's North American Nebula. Duh. Okay, I got my bearings.
Curtis Horn was asking for 7822 the other night.
Yeah, he was.
If we ever looked at it.
Well, let's find it. Make sure we can find it. It's right there. We have the we have that guy. That's a big nebula. We have the Little Rosette right here, which is a different cluster than the Rosette Nebula, incidentally. Alright, so this...
That's big.
Yeah. Well, maybe we can image the dark dust in here. Let's go right to there and see what we can do. It'll be upside down. You'll see the crosshairs show up in here and go dead center on that X in just a minute. Here it comes. All right. Okay. Alrighty, so now...
I didn't see it move.
You didn't see what move?
The field in the camera. I mean, I saw Stellarium move, but...
Oh yeah, it moved.
Okay.
It did. Okay, so... Let's capture this, see what we got. We'll do a 30-second shot here. It is now underway. Off we go. Alright, and into our live stack. This is NGC 7822. We're going to come back to this one at some point. Maybe with SHO setup. Okay, first in our lineup. Yeah, we got it.
Nice.
That is 7822. There's the pillars that we've seen very often in 7822. Alright, let's color correct number 1.
Did we look at this a couple of nights ago?
Yes, we did.
Oh, okay. So I was thinking, darn, that one big pillar sure looks familiar.
Yep.
And the little skinny one to the left of it. It's just starting to show up.
Yeah.
Okay.
Okay. Let's go. While it's doing its thing and coming in, let's take a look for something else. This one's a pretty small galaxy. Well, sadly, we can image the double cluster and the heart.
We just got the fish head the other night.
Yeah. Well, the nice thing is there's always something else to look at, you know. Right after this, we'll do the double cluster, and then we'll do the heart. I think that'll be cool. Alright, so let's do this. This is a stellar nursery, as we've talked about before. Full of dark nebula here. You can see it very clearly. This view almost looks 3D. And as we do this, it'll look even more that way. And so this gives you this beautiful view of this amazing gossamer streamers of black dust coursing through this beautiful stellar nursery. Young hot star cluster up here that formed in here. Now the reason that the sun has a sibling that is almost identical in composition stands to reason when you look at this cluster. This cluster is full of stars that all formed in the same place from the same pool of materials from a same nebula. So it stands to reason that that pool of materials will all be similar for that region of space. So wherever the sun was formed with another star or more. That's how we know that we have siblings, is when you can find the other stars that are the not similar composition, but exact same composition as the sun. And then you will know. Wow. You're watching on UFO Bros watching on an 80-inch 4K screen. Yeah, nebulas like this show up beautifully on that type of screen. Make sure, everybody, that you're on 1080p as well. We're gonna investigate doing this in 4K. I was at one point doing it in 4K, but we abandoned it because we didn't have the bandwidth. But now with Starlink being our service, we might now have the bandwidth to use our 4K system again out there. Just thought of that. Look at this beautiful band of very convoluted dark nebula, Darrell. Look at that. Mm-hmm. Comes right across. Look at these filaments connecting each other.
Yet that the very red part there over on the far right.
Yeah, and then you got these filaments sticking out from it. This is really cool.
Looks almost like a fish. Looks like eyes in it.
I guess. There we go. I had to put on our sunglasses. It was too bright. That's neat. So you can almost see the three-dimensionality here. That's purely an illusion in all likelihood, but still, you can kind of see how it looks like you're moving into a valley of ionized hydrogen. And streaming 60 frames per second. Yes, Izabela. Thank you. Okay, we got 15 here. That's good. And this will be NGC 7822. Not 33. The wrong number came out. Okay. And so we'll save it. Save it exactly as seen.
What happens when you save it both ways like that?
The FITS file is saved the first time, and then the PNG file that looks exactly like this is saved the second time. So all the processing that I did right at this point is shown. If I were to move this or do this, for instance, okay, and now we get that, and I say save as seen, then exactly this is now saved out there.
Okay.
So you can see kind of what's out there. Kind of a cool idea too, actually. All right, now let's go back to our 1 second and do our night vision mode. And now we're gonna go to the double cluster. For the first time this year, first time with this camera, double cluster should fill this field of view.
Yeah, you probably only catch one cluster at a time now.
I think we'll get them both, but they're gonna be really filling the screen, see?
Oh.
Okay. With the other camera, both clusters filled just a small section like this.
Well.
Alright, so now we come down. Oh yeah. We'll go west, young man. Guys, if you like it, please show us some love. Show us a few likes. Help us trend. Join our Patreon. $3 a month. I mean, you know, you'll get some perks for that. I haven't figured out what those are going to be yet, but we got them. Look at that. Yeah, this is a double cluster. First time this year we're looking at double cluster. First time with this camera ever. There we are. So we're searching now, and we're going to just do a 25-second shot of this. Just enough to get the rich colors of the stars. And you're going to see, like here and here and here, there's some red supergiants in this cluster, indicating that this cluster has evolved. Now, this one here, or this one here, I think this one is closer to us, and it looks more distended. The right one is a little further away, so it's a little bit more compact. Alright, so let's go in here. No. And we're going to say clear. Okay. Now, when we talk about SkyTour Livestream, we talk about bringing you the universe live in real time and showing you gems in the universe. This is 2 boxes of gems. Okay, look at this, 2 boxes of beautiful gems. Let's get rid of that to bring it down. Look at that. Beautiful gems out there. Color correction shows you the proper colors now. Look at those red giants out there.
Nice.
Yeah.
I know we've talked about this before. They do belong to the cluster, correct?
Yeah.
Yeah.
So what that means is the stars themselves kind of held themselves together and did not did not wander away. So they evolved in place.
Yeah. Ray is asking you a question.
about 12-bit. I'll look and see. I don't know. Yeah, I could output TIFF files too, which I don't. And I could save also. I could save each individual frame before we stack it, but I don't have enough space in the server. Yes, Cosmic Ray is right. This looks fantastic in a binocular eyepiece. That's true. That's a stunning cluster. I can go right into it. Oh, you see we got to focus again. That's all right. All right, we'll save this with 6 frames. Save exactly as seen. And then come on out, and from night vision mode we'll end up doing another focus run.
I was going to say earlier tonight, it looked like your temperature is supposed to drop a fair bit in Arizona tonight.
Yeah, it's 23.8 out there now. Okay, we're going to focus inward. And the focus now is going to build a focus curve down here, a parabola, like this. And that parabola has a central lowest point. That lowest point is the best focus. And as the telescope passes through that, it'll interpolate the curve, and the telescope won't necessarily hit that focus spot as it's doing this, because it's doing 12 discrete sets of point captures. All right, so it'll find the best focal score, as it's called, and when it finds the best focal score, it's going to make that the lowest point in the curve. And if it's not quite where it's sampling, it builds the curve, and wherever that lowest point is on the curve, then it will figure out what that point is, and that's the value that will be set for the focus. You can see already that it's probably going to be right about here. When you see the line show up, it's going to be right there, up right here. There it is. Okay, so we can immediately go right to our best focus, and it goes all the way across and back into perfect focus. Alrighty. Okay, so now let's do this. Now that we got it, let's come out of here, and we're gonna go into the center of the Heart Nebula. Because there's an interesting set of features right in the middle here. They're really cool. I believe that's it right there. So let's come back out of here. Yeah, okay. So we're going to go up just a little bit. There we go. And now you're going to see some most amazing details show up out of nowhere here. "25 seconds. There's our beautiful image, which I took a snap of. It's on a folder. And this is going to be the Heart Nebula. And it's the Heart Nebula core. This is the most unbelievable, convoluted gas clouds and dust clouds that I've seen in a nebula in a long time. This is really pretty right here. That's what we're focusing on. It's the Heart Nebula core. Okay. Alright, let's drop this over here. Start pulling out this detail. Did Izabela just go off the grid? Is that what you said? Gladys said
That's what I was wondering. Her last comment I see was, you are also streaming 60 frames per second.
Yeah. Oh, look.
There she is.
She's still there. See that, Izabela? We miss you right away as soon as you go.
This is a nice picture.
It is. See, more pillars over here, guys. Again, hot young cluster makes pillars. So we'll let this develop for a while because this is going to be really pretty. Let's see where it wants to be. It's going to pull us out. Izabela, you'll miss me when I'm gone. I did miss you when you were gone. You just disappeared.
I think she's quoting me.
I know she is. Look at that. That's pretty. Let's remove some noise. Hey Louis, how you doing?
I know it's never safe to assume such things, but the brightest reddish area up in the upper right looks like that bright star is what's illuminating it.
Yeah, you're right. It's never safe to make those assumptions. So I'm not sure, but I do know that's the Heart Nebula core we're looking at right now.
Looks really cool.
Yeah. Look at that. So this is pretty much the core of the Heart Nebula. With the last camera, the field of view was massive, and we could actually see the entire Heart Nebula in one shot. but we lose detail that way.
I know when we imaged the fish's head the other night, which is one of the top corners in the Heart Nebula,
upper right.
Just taking a glance at the field in Stellarium, it looks like it'd take you 6 or 8 or 9 images to build a mosaic of it now.
Yeah, maybe. It would be high res. Look at these beautiful details. Again, some of that we could see with the other camera, but most of it was lost to us. Wow, that's really pretty though. Look at this detail in here. Holy cow. That is new to us. Let's see what's really here by doing this.
I'll amend what I said earlier. That area at the upper right, I mean, I assume it's that whole cluster of stars that's lighting up all this.
I believe that that is true. Look at that. Oh, Izabela, you should do the cave. It's up there. We did the cave the other night. Wow, this is really nice.
Yes, it is.
And we have Izabela's favorite song here. Gymnopedia. Okay, so now oh, look at that. This, guys, is what we call a really complicated nebula. Really complicated. I think Izabela was saying it is. Well, these nebulas are they do similar things, Izabela. You know, they drive away when their stars wink on as a cluster. They drive away other gas and dust, clearing a cavity around them of some sort. Okay, we see that's happened around this cluster. It's been pushing stuff away. Other processes have shaped this general region, and it could be from supernovae in the past. It could be from stellar winds from other stars that were formed. A single O star could have done it. Hey there, M. Turner. How you doing?
That really pops.
Yeah, you know what we're going to do? We're going to actually remove this for a while. And remove that. So now you get to see the whole thing. That's probably the best thing to do. Move that down there. Look at that. I'm a really big fan of these. Look at this beautiful dark stalk right there. That is neat. This is cool here. This is, again, this dark dust in here again, light years across, is part and parcel to the very fundamental building blocks of life, because those are in there in some form or fashion, without a doubt. Now let's zoom in, shall we? Wow. This is live astronomy, folks. This is live, the universe live in real time. We have taken 23 frames so far. We'll go to 25 on this. Wow. This is, I can't get over how amazing this looks. It's like this little hook with lots of detail in it. Really, really incredible. And I'm gonna just let it do what it wants to do. And then it's gonna pop right in front of your face here. There you go. And we'll take this down for just a moment. Look at that detail. Actually, now we can go to enhancement. If we turn off the sharpening, okay, you don't really see much of a difference. But if we turn on the sharpening and increase it quite by a lot, then you'll see something very different. It'll be even more detailed. Now you see details in here that were just completely missing moments ago. Wow. Alright, let's dock the bottom up anyway.
I kind of see a mermaid in that upper right part.
Up here. Head, arms.
No, farther down, right there, right in the middle.
Okay.
That's
I
tail,
see it.
That's
Yeah, I
her
see
body.
it. Yeah.
Her
Head, arms outstretched. Yeah. Pareidolia is a wonderful thing. That's cool.
Too much LDS in the 60s.
That's right, Spock. Wow, look at that. Okay, so that's good. There's the Heart Nebula core. Saving that. Saving it exactly as seen. That's going to make a beautiful image. That's gonna make a beautiful image. Wow, guys. Well, I think that's a great image to end on, don't you? I know that not many people go away pink. Not many people want us to end right now, but I think we have to.
Always leave them wanting more.
Oh, I know, and then I always do one more anyway. All right. That's really nice.
Oh, that's a good one to end on.
Yeah. So we'll catch you again. We will be back And as a matter of fact, let's bring the telescope back. Here. We are. We'll catch you very soon.
Wants just one more.
I wish I could. I'm holding on. I know you want the Soul Nebula, but I want to do it justice and spend another 15 minutes on it, and I'm running on empty right now.
Okay. I'm getting there too.
So guys, thank you for coming out. Thank you for being with us, and do hit the like button. We really need that. Ever since my Facebook profile was hacked and taken off of Facebook by these folks in India, I've had to start that all over again. So I lost 10 years worth of photos, articles, documents I put up. But they all originated from me here at this end, except for the posts. So all the captioned photographs for SkyTour were lost, unless I can somehow get those back at some point. But we'd appreciate it if you could, join the Patreon, support us that way if you can. $3 a month, not too much to ask for what I think you get. I think we do a bang up job, Darrell, don't you?
Pretty good.
Yeah. All right, guys. We have a good evening, and we'll talk to you the next time we go live. Probably day after tomorrow. But I do like to do a lot when the moon cycle is on the back wane, the back 40 as we call it. So we'll see you guys, and have a really, really good night.
Good night, everybody.